Hello, everyone. So the topic for the discussion is smart device for air and sound pollution monitoring system. Firstly, getting into the introduction, air and sound pollution is a growing issue these days. It is necessary to monitor air quality and keep it under control for a better future and healthy living for all. Here, we propose an air quality as well as sound pollution monitoring system that allows us to monitor and check live air quality as well as sound pollution in a particular area through IoT, which is the Wi-Fi module. The system uses air sensors to sense the presence of harmful gases and compounds in the air and constantly transmit this data to the microcontroller. All the system keeps measuring the sound level and reports it to the online server over IoT. The sensors interact with the microcontroller, which processes this data and transmits it over the internet. This allows authorities to monitor air pollution in different areas and take action against it. And also, authorities can keep a watch on noise pollution near schools, hospitals, and no honking areas. If the system detects air quality and noise issues, it alerts authorities so they can take measures to control the issue. Uh, Next, getting into the hardware components, we have MQ135 gas sensor, Arduino Uno, Wi-Fi module ESP8266, and L16 into 2 LCD, breadboard, 1K ohm resistors, 220 ohm resistors, buzzer, and the software requirements we have are Arduino integrated development environment and embedded C language. Getting into the hardware components, the pollution sensor, which senses and monitors the presence of air pollution in the surrounding area, and as well as the microcontroller. It is a small computer on a single metal oxide semiconductor integrated with the circuit chip. It contains both one or more CPUs along with the memory. And the LCD indicator used for indicating warnings and accidental signals. This is the sound sensor. It detects the sound waves through its intensity and covering into electrical signals. Regulated power supply, which is nothing but a power supply, ensures that the output remains constant even if input changes. It is also known as a linear power supply. Getting into the communication interface, here in this project, the only communication interface which we use is ESP826's Wi-Fi module, where the ESP826's Wi-Fi module is a self-contained SoC with an integrated IP protocol stack that can give any microcontroller access to your Wi-Fi network. The Wi-Fi module is capable of either hosting an application or offloading all Wi-Fi networking functions from another application processor. Every ESP826 module comes pre-programmed with an AT command set firmware, meaning we can simply connect to the Arduino device. The ESP826's module is an extremely cost-effective board. Here we have the system architecture and the block diagram and the connections for the hardware components. And next, here the system architecture involves the MQ135 sensor can sense NH3, NOx, alcohol, and other harmful gases. So it is a perfect gas sensor for our air quality monitoring system. When we will connect it to Arduino, then it will sense the gases and we will get the pollution level in ppm, which is parts per million. MQ135 gas sensor gives the output in form of voltage levels and we need to convert it into ppm. So for converting the output in ppm, here we have used a library for the MQ135 sensor. Sensor was giving us a value of 90 when there was no gas near it, and the safe level of an air quality is 350 ppm and it should not exceed 1000 ppm. When it exceeds the limit of 1000 ppm, then it starts causes headaches, sleepiness, and stinks and stuffy air, and it affects its 2000 ppm. It can cause increased heart rate and many other diseases. So next, coming into functional requirements. Here the functional requirements are the air quality pollution monitoring system allows us to monitor and check live air quality in a particular area through IoT. The sensors interact with the microcontroller, which process this data and transmit it over the internet. This allows authorities to monitor air pollution in different areas and take action to control the issue. Here we propose an air quality pollution monitoring system that allows us to monitor and check air quality in the particular areas through IoT to sense the presence of harmful gases and constantly transmit the data to the microcontroller. It also the sound pollution in particular areas is captured, and this data will be processed through the Wi-Fi module, which has been arranged for a particular frequency and volume level. This triggers and make an alarm sound which transfers the data through the internet worldwide. Here are some non-functional requirements, which are like reliability, accuracy, scalability, security, and usability. Reliability is nothing but the system provides reliable and which is available 24 by 7 to monitor air and sound pollutions. Accuracy is nothing but the system provides accurate readings of air and sound pollution levels to ensure the accurate data is collected. Scalability is the system is capable to scale up or down depending on the size of area to be monitored. And security is nothing but the security measures in a place to prevent unauthorized access to the data collected. Usability, the system is easy to use and data collected should be presented in a user-friendly format that is easy to interface. Here are some more the non-functional requirements like performance, compatibility, and availability. And in the end, we have this operational environment where we have the geographic location. The system may be deployed in urban, suburban, or rural areas, and the environmental conditions such as temperature, humidity, and altitude may differ. Climate. The climate of the operational environment can affect the performance of the system as extreme weather conditions such as heavy rain, snow, high winds damage the sensors and equipment. Air quality, the level of air pollution in the operational environment can affect the accuracy of the readings collected by system, and the system should be calibrated to account for local air quality conditions. Sound levels, the sound level in the operational environment can affect the performance of the sound sensors, and the system should be designed to filter out the background noise. And in the end, this power supply, the system may require a reliable and continuous power supply, which can be affected by power outages, blackouts, or voltage fluctuations. Thank you.